Okay, so in this unit we're going to look at a new kind of graph that you haven't seen too much of. Specifically, we're going to look at something called a sinusoidal function. But before we do that, we're going to look at a broader type of function called a periodic function. And again, we haven't seen too much of these before, but a periodic function is any graph or any function that repeats at regular intervals. So here's a graph of one below, and again, it's a little bit familiar to us. We've definitely worked with sine x before in terms of solving triangles. We've never done a graph of sine x. So if you think about what this would be x being a certain degree and y being the value of the ratio. Okay, so here's a pretty good idea of what the graph looks like, and you'll notice that there is actually a pattern here. It goes up and down, and repeats at regular intervals. Okay, so we're going to see lots of kind of graphs that do this. In fact, I'll show you some examples here in the next slide, again, of other graphs that repeat at regular intervals. Okay, so when we're dealing with graphs that are what we call periodic, again, repeating at regular intervals, there's a lot of certain features that go along with them, mainly dealing with things called cycle, period, and there's an axis and things like that. So let's take a look at what all these things are. A whole bunch of new definitions for us to look at, and we'll see what we can do with them. So first off, when you have a graph that repeats, what you're looking for is different cycles. So a cycle is one complete portion of the graph. So what you're seeing here is several complete cycles. So you'll see, let's just say we started here, we'd have one cycle going from here to here. Then it would start again, go another cycle from here to here, and so on and so forth. So a cycle is, again, the smallest complete portion of the graph which repeats. So let's say I started at the maximum value here at negative 630 degrees here, and went to the maximum again, where it starts repeating. This right here would be considered one cycle. Okay, I could also take a look at a cycle going from here to here, and that would be a cycle as well. Okay, I don't necessarily have to go from maximum to maximum. If I wanted to, I could go look at the minimum here and go from here to here and call this a cycle. Okay, or if I really wanted to be more adventurous, I could go on the axis here and go from here, not to there because that's not a full cycle, it's not repeating, but all the way up to here would also be a cycle. Okay, all these would be valid cycles. And again, you're just looking for a portion of the graph that repeats. Okay, now, specifically now, once we have a cycle isolated, the period, if you've been in physics, you might have looked at what a period is, but a period is just the length of one cycle in terms of its independent variable. So let's just say we look at our red cycle right here, going from negative 270 degrees all the way up to 90 degrees. The period length will be how, the change in x over the course of that one cycle. So if we're going from negative 270 degrees to 90 degrees, well, what's that a difference of? Well, 90 minus negative 270 is a difference of 360 degrees. So in this case, we have a period of 360 degrees. And again, since all the cycles we choose should be the same length, it doesn't matter where we go from, we should get the exact same answer. So let's just say I decided to start here at 0 and go all the way out here. You'll see once again I have a cycle 360 degrees. A period of 360 degrees covering that one cycle. Okay, and so that's cycle, that's period. The next thing we have is an axis. So when we looked at parabolas, we talked about the idea of an axis of symmetry being a vertical line that cuts the parabola in half. Well, with a periodic function, what you have is a horizontal axis that's going to go halfway between the highest and lowest values on the graph. So let me just clean up this graph here. Okay, so what I want to look for here to find my axis, again, it's a horizontal line that's halfway between my maximum and my minimum. So my maximum value here, see the highest value the graph reaches, this particular one anyways, is 1. Okay, the smallest value my graph reaches is, well, there's lots of spots, so let's say I look at here, is at minus 1. So my axis would be the horizontal line halfway between the maximum and the minimum. You can sort of see it on the graph, halfway between 1 and negative 1, you get an axis at 0. So let's say I plot that axis in. Okay, that would be my invisible axis of this curve. Okay, and it would have the equation y equals 0. Okay, again, since it is a line, it has to have the y equals. I know it was x equals for axis of symmetry, because it was a vertical line. It is a horizontal line, so it has the form y equals. Okay, so one way you can find it, we were able to nicely visually get this from the graph, but in general, it's a maximum value plus the minimum value divided by 2. So in our particular case, our maximum value, our highest y value is 1. Our minimum value is negative 1. So 1 plus negative 1 divided by 2, 1 plus negative 1 is 0. So that gives you the equation of the axis right there. Okay. Once we have the axis, we can talk about something called amplitude. So amplitude, again, if you've done physics, then the word amplitude has come up when you're studying waves. But again, if you haven't done it before, that's okay. So it's half the distance between the maximum and the minimum. It's one way of looking at it. Okay, so we can think of it this way: if the max is 1 and the minimum is at -1, the distance between the maximum and the minimum is going to be 2. Okay, and half that distance is going to be 1. That's our amplitude. The other way we could think about it is the distance between the axis and the maximum, or the axis and the minimum. So once you have that axis drawn on here, we can say, okay, from the axis up to the maximum is a distance of 1, and from the axis to the minimum is also a distance of 1. Should make sense. They should be the same because the axis is halfway between the max and the min. So either way, we get an amplitude of 1. Okay, so two ways you can calculate that. You can either take the maximum value, which in this case is 1, subtract our axis, which is 0. So in that case, we'd have 1 minus 0. Okay, or we can go maximum minus our minimum divided by 2. Again, if you don't have a graph and you're looking to calculate it, this would be another way of doing it. So our maximum is 1, our minimum is -1. So 1 minus -1, all divided by 2, which is 1 plus 1. So again, we get our amplitude that way. One thing I'd like to point out is the amplitude is a distance, so it cannot be negative. Okay, that can come up sometimes if you see that if you're going from the axis down to the minimum, some people might think it's a negative distance. But remember, distance is a positive value, so the amplitude cannot be negative. Okay, and again, these are all features of this graph. Now again, we haven't worked too much with y equals sine x before. We're going to be studying a lot more over the course of this unit, along with y equals cosine x. But this is just an example of something that we call a periodic function. Now, the graph of sine x and the graph of cosine x, just to remind you what it looks like. So here's a graph of y equals sine x. I'll put the y equals cosine x on there as well. And you'll see it's a very similar shape. They're just off by a little bit of a shift, which we'll discuss more later on in this unit. But these types of graphs and any kind of transformations of these graphs are called sinusoidal graphs. Okay, so these graphs are also periodic, but since there are transformations of sine x or cosine x, we also call them sinusoidal. So I briefly showed you this slide earlier, but on this page right here, we see other examples of functions that we call periodic, because again, they repeat at regular intervals. Okay, we got one there, and one there. Okay, none of these are considered to be sinusoidal. Sinusoidal would be a transformation of sine x and cos x, which we're going to work a lot more with later on in this unit. Okay, so just make a note to yourself just so we have those terms down, that sinusoidal graphs or sinusoidal functions are transformations of y equals sine x or y equals cos x. Okay, and they'll have a shape very similar to the graph I've shown you guys here of sine x or cosine x. They'll just be transformed. Again, we'll talk more about that later on. But any graph that repeats at regular intervals is considered to be periodic. So sinusoidal graphs are periodic, but periodic graphs are not necessarily sinusoidal. Okay, so what I want to look at now is just a couple of examples of graphs and just have us find all those main features. So the equation of the axis, the amplitude, the period, and we're also going to look at bring back the whole idea of range from Unit 1. So let's look at this first one together. So this graph, you can see, has a very similar shape to what we saw looking at sine x or cosine x. This one is actually sinusoidal as well as periodic. We'd like to figure out first the equation of the axis. So visually you can see it on the graph. And you can see that the value in the middle here, the y value in the middle that cuts it in half, is going to occur at y equals 5. Okay, so which is all well and good, but again, let's say you're having trouble seeing it on the graph or it's not an exact value. You can always calculate it by going max plus min divided by 2. So in this case, our maximum value is at 7. Our minimum value is at 3. So you go 7 plus 3 divided by 2, which again gives you y equals 5. Okay, so you kind of get it visually from the graph, but also know that you can calculate it as well as long as you have the max and min value. Okay. As for the range, Okay, we didn't really discuss this on the first slide, but again, range is a concept that we looked at back in Unit 1. So it's all the possible y values on the graph. And once we have our maximum or minimum value, we can actually get this. Because if you'll see, if you look at the domain, this graph is continuing on forever, left to right. So the domain is going to be x is an element of the real numbers. Okay, but we're interested in the range here because all y values are not possible because there is a maximum minimum value. So if our minimum value is -3 and our maximum value is 7, all the possible y values are the ones in between. So we say y is greater than or equal to -3, but also less than or equal to 7. Okay, and that will be the range of this function. Okay, as for our amplitude, remember amplitude is the distance from the axis to the maximum. So on our graph right here, our axis is here at 5. Our maximum is at 7. So counting from our graph from 5 to 7, this should be an amplitude of 2. Okay, so you can get that from the graph, or you can remember it's maximum minus the minimum over 2. So if you go max minus min over 2, it would be 7 minus 3 over 2, which gives you an amplitude of 2. And so again, 2 ways of getting that one there. Okay, as for the period, okay, so let me just clean up this graph here for a bit so we can work with it a little bit easier. So the period, remember, is the length of one cycle. So what we need to isolate is one complete cycle on the graph. And again, where you choose to start and end your cycle is up to you, as long as, again, you're only choosing one cycle. So one of the easiest things to do, especially with a sinusoidal function, is either go from maximum to maximum to get a cycle, okay, or you can also go from minimum to minimum for a cycle. Okay, those are probably the two easiest ways, but the other option that you have is to go from, is to stay along the axis. So let's just say you decide to start your cycle here, you could go out and complete a cycle over there as well. And again, either one of these works. It's just a matter of preference, or also sometimes depending on what's easy to read off the graph, right? If you don't have nice values to read, maybe you'll pick the one that works nicely for you. But in this particular case, all of these are nice values to read. Let's say I work with the blue one right here, so I start at the maximum here and did one cycle right here. So the period, if we start here using our scale, the cycle starts at 30 degrees and it ends at 90, 120, 150 degrees. So the length of that cycle would be 150 degrees minus 30 degrees, which should be 120 degrees. Okay, and again, that should be the same regardless of which cycle you choose to work with. Okay, so again, that's just looking at a graph and getting all the main features of it. There's one here I'd like you to try on your own. So look at the graph, try and find all these 4 pieces of information, and push play when you're ready to go through it together. Okay, so you can quickly check your answers. So the equation of the axis, again, if you visually from the graph, you might be able to see it's at y equals -2. But alternatively, you can just look at the maximum minimum values. So the maximum is at 3, the minimum is at -7. Add them together, divide by 2, and you get an axis at y equals -2. Okay, because my minimum is at -7 and my maximum is at 3, the range will be any y value between -7 and 3. For the amplitude, I'm going again from the distance from the axis up to the maximum. So if my axis is at -2, okay, and my maximum value is at 3, I can count that off as being a distance of 5. And that's about it for the period. This one's a little bit trickier to do because if you try to go maximum to maximum or minimum to minimum, the values are not necessarily nice looking on the graph, a little bit harder to read. It does turn out they're on the 0.5s. This would be -4.5, this would be 5.5, but it's a little bit harder to read. What's a little bit easier here is to actually go stick along the axis to isolate your cycle, because on the axis, when the graph's on its axis, the values are, again, much nicer to work with. So here I started a cycle at -2 and ended it at 8, and again, those are nice values to read. So going from -2 to 8 is a distance of 10, so the length of that cycle, which is the period, is 10. Okay, so that's it. That's all for this one. There's some homework there to help you get used to using these definitions. And next we're going to start looking more in depth at sin x and cosine x and those graphs and those transformations. Okay, cheers.